Hey guys, this is chapter 11, section 2, triangles. Some of this section will feel a little bit like review, but that's okay. We're going to add to some of the stuff that you learned in elementary school just regarding triangles. So a line segment is part of a line that has two endpoints and all of the points in between them. A triangle is formed by three of these. So if I have one line segment, it's got a starting point and an ending point, and I put it with another line segment connected at the endpoints, and then I connect those other two endpoints by another line segment, I have a triangle. Triangle has three sides or three line segments that only intersect at their endpoints. The three angles that lie inside the triangle are formed by segments and the vertices. These would be angle 1, angle 2, and angle 3. They're inside. They're in the interior of the triangle. These are called the interior angles. The sum of the measures of the interior angles of a triangle is 180 degrees. So sum means I'm going to be adding them together, and I would be adding all of the interior angles, which would be angle 1, angle 2, and angle 3, and I would get 180 degrees. So I could write it out like this: the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 will be 180 degrees because I have a triangle. I could label these vertices. I could say this is X, Y, and Z. I could say the sides of the triangle are side XY, side YZ, and side XZ, all the line segments. I could see that these sides form vertices. I have vertex X, vertex Y, and I have vertex Z. And then also in the triangle I have three angles. I could call it angle X, which would be the same as angle 1. I could say I have angle Y, which I also named angle 2, and I have angle Z, which I also named angle 3. And we know that those three angles, whether you say them as 1, 2, and 3, or you say them as X, Y, and Z, they add to 180 degrees. So this says, find the measure of angle E in triangle DEF if the measure of angle D is 62 and the measure of angle F is 39. So since I have a triangle, I know that all of the angles, when you add them together, equals 180 degrees. So after I write that out, I'm going to fill in the information I know. I do not know the measure of angle E. I know angle D is 62. I know angle F is 39. And I know they add to 180 degrees. So by doing this, I have one variable and two that I already know. So I'm going to combine my like terms. I'm going to do 62 plus 39 first. Then I'm going to subtract 101 from both sides to find that the measure of angle E is 79 degrees. So again, that might be something that some of you can do in your head, but remember, we are writing out our work. What if the problem gives you a ratio? So we've talked about ratios before. and ratios are always written in simplest form. So if we are given something in simplest form, we may need to unsimplify it, work backwards. So first we're going to note that the measure of the angles of a triangle add up to 180 degrees. Now when you simplify something, you are dividing out a common factor. So if we're working backwards, instead of dividing, we are going to multiply. We're going to multiply each ratio by x, because right now we don't know what that common factor is. Then, since we already know that all the angles add to 180, we're going to add them all up and set them equal to 180. We can then combine our like terms, solve for x, and plug it back in. So let's work with numbers so you can see what I'm saying. The measures of the angles of a triangle are in a ratio, meaning this is written in simplest form. So it's not saying that one of the angles is 1 degree, and one of the angles is 3 degrees, and one of the angles is 6 degrees. We know that because is 1 plus 3 plus 6 180? No, it's not. So this is going to be in simplest form. So let's go through our steps. First, we know that the measures of the angles of a triangle add to 180 degrees. Now, we're going to multiply each number in our ratio by x. So I'm going to say 1 times x plus 3 times x and 6 times x. Step 3 says add up all the measures, which I kind of already did as I was writing them, but I need to set them equal to 180. So we're working backwards, we're unsimplifying here. Combine your like terms and solve for x. 1x plus 3x is 4x, plus 6x is 10x. So I can solve for x by dividing both sides by 10. Okay, but I'm not done. I've solved for x. I just finished step 4. Now I need to plug it back in to solve for each of the values, because it doesn't ask what my common factor is. It doesn't ask what my x is. It wants me to plug it back in. So I'm going to have 1 times 18. I'm going to have 3 times 18. And I'm going to have 6 times 18. Now you can check your work and add all of those up, but when you add those, you do get 180 degrees. So I solved for each of them, even though I was only given the ratio of 1 to 3 to 6. So now I could divide out 18 from each of these answers and find that I get 1, 3, and 6. So it's just working backwards. Instead of simplifying, we are expanding it out to find the measure of each of those angles. Okay, so that was everything having to do with the interior angles. Now what about the exterior? Each exterior angle of a triangle is formed by one side of the triangle and an extension of the sides next to it. So if I were to draw out my triangle like this, we know we have 1, 2, and 3. These would be our interior angles because they're inside the triangle. But if I extended the sides, I now have exterior angles. I have an outside one here that's formed by the extension and one of the sides. I have an outside one here that's the extension and one of the sides. And I have another one, extension and one of the sides. An exterior angle is supplementary. We learned that last section. Means it's going to add to equal 180. To the interior angle, it was next to. Next to, I told you to think of adjacent. Okay, so if I were to write these out as equations, I could say I have all of my interior angles, and if I add the exterior angle it's next to, I will get 180. So the one that's next to angle 1 is angle 4 because it shares the vertex and this side. The one that's next to angle 2 shares a vertex and a side would be angle 6. And the one that's next to angle 3 shares a vertex and a side would be angle 5. It says that these add to 180. One of the things I mentioned with supplementary from last section was that supplementary meant it formed a straight line. If you look at your picture here, 1 and 4 make up this straight line. 3 and 5 make up this straight line, and 2 and 6 make up this straight line. So they all form supplementary pairs. They're adjacent pairs that are supplementary, meaning they add to 180. So in your book, example 3 on page 504, there is a director's chair. And I'm going to draw out what we're concerned with here. It's kind of outlined in red. Okay, but it says this is 1, this is 2, this is 5, and this is 4. It says suppose the measure of angle 4 in example 3 is 102 degrees. So this right here is 102 degrees. It wants me to find the measure of angle 1. Well, if I look, angle 1 and angle 4 are adjacent. They share that side and that vertex. They also make up a straight line. One is interior, one is exterior. So I just learned that adding those two together, I get 180 degrees. They're supplementary. So I'll plug in 102 so that I can subtract it from both sides to solve for the measure of angle 1. And I get 78 degrees. So this last part is the part that I think is probably review for most of you. Acute is anything that is smaller than 90 degrees. So if we're classifying these triangles, an acute triangle means it has all acute angles. Okay, we're looking at less than 90 degrees. Obtuse means bigger than 90 degrees. An obtuse triangle has one obtuse angle. Remember, all of the angles add up to 180 degrees, so there can be at most one obtuse angle in a triangle. Right means it's exactly 90 degrees. So we can have one right angle in a triangle. So an acute triangle has all acute angles, meaning all angles are smaller than 90. An obtuse triangle has one obtuse angle, meaning it has one angle that's bigger than 90 degrees. A right triangle has one right angle, which means it has one angle that's equal to 90 degrees. These are how we classify the triangles by angles. Another way to classify triangles would be by side. So scalene triangles have no congruent sides. They're all different sizes. Isosceles has two congruent sides, and equilateral, well, equa means equal, so you might be able to figure out it has all congruent or all equal sides. You'll notice it has these little like tick marks on it. That's telling me which sides are congruent. So scalene triangle, you'll notice it has none of those marks on it. No sides are congruent. Isosceles triangle, you'll notice it has two. Those two sides are congruent. And the equilateral triangle has the marks on all of them, which means all of the sides are congruent. So, a little bit of review again, but congruent, we said another word for congruent was equal. Congruent sides are sides that have the same length, same or equal length. So if you know one of the sides, you can technically know all of them if, say, they're all equal. So let's see. These ones want us to classify each triangle by its angles and by its sides. So if I was giving a picture like this, it says 58 degrees, 80 degrees, and 42 degrees. First of all, let's look at the angles. All of the angles are smaller than 90 degrees. That means when I classify it by angles, I would say it's acute. Now I notice that none of the sides have congruent marks on them. That means that no sides are congruent, so this would be scalene. Okay, this last one so let's look at the angles first. All of the angles are smaller than 90 degrees. That means this is acute. I also notice that all of the sides have congruent marks on them, which means all of the sides are equal. This would be equilateral. If we took this one step further and say this side was 12, and this side was 3x, and this side was, well, let's just leave it at these two. Making up a question here. What if it said solve for x? Well, based off of this information up here, it says congruent sides are sides that have the same length. And I notice that there's a congruent mark on each of these. I could say 12 equals 3x because they're congruent. I know they're going to have the same length. And I could solve for x. I could figure out that dividing both sides by 3, my x equals 4. I could also figure out, well, if this side is 12, then this side is going to be 12, and it's equilateral, so this side is 12, even if they didn't give me any information for that third side. I could solve for x, or I could tell you what all of the sides are. I also realize I spelled equilateral wrong. There we go. All right, so that concludes section 11.2 on triangles.